Writing code is easy, being a great developer is hard. So I wrote this talk because I graduated over 20 years ago from Sussex with a stereotypical computer science degree. And I went into my first job as a Java programmer, because what else do you do when you study Java at university? And I failed spectacularly. I failed so badly that I quit my job. I left the country. My mum wouldn't have me back. It was just a bit of a mess, to be honest with you. And I then spent some time, well, a lot of my career doing technical writing, which I loved. And I was still working with developers, which I loved. And throughout that time, I convinced myself that I couldn't do programming and I couldn't do Java programming and I was rubbish at it and all the other negative chat that goes along with that. Now, I then came full circle just over 18 months ago, and I was encouraged, I think is a fair word, to join JetBrains as a Java developer advocate. And I had all that negative self-talk going on at the time, and I thought, I can't do this, really can't do this. But I did it, and I discovered something really interesting. I discovered that I can do it, and everything's a lot easier this time round. And I'm not sure why that was. And that's where this talk come from. I couldn't work out why things were so much easier this time around. Granted, I drank less. That's a given. I wasn't working on Corba. Didn't like Corba, for those of you old enough to remember it. So my hypothesis is that learning code is the easy part. I'm not saying it is easy, but I'm saying it's the easy part. And it's all the other stuff that we have to learn on the job that's the hard part. I have left JetBrains since then because I was offered a really exciting opportunity at MongoDB that didn't want to turn down, so I didn't. But everything in this talk is still relevant. So nobody shouted up, so I'm assuming you can see my presentation, so I am going to get started. So where do we learn? Where do we learn to write code? Predominantly 3 different routes. They're very stereotypical, and I've generalized at this point. So you've got university. It's my route. This is not about which route is better, by the way. That is completely separate talk, and none of them are better. University is very theoretical, spread over 3 to 4 years. You've got boot camps. So they're a bit of a mix. You've got theoretical and practical, and they're spread over 1 to 3 months as a rule. You've got self-taught. Now, if you're on this call and you're a self-taught developer, I take my invisible hat off to you because I think that's amazing. And it's a very, very practical approach, as I'll come on to. Certainly in the UK as well, we've got apprenticeships. They're quite up and coming. They all have advantages. Arguably, they all have disadvantages. But let's take a look at what topics might be covered in each of these learning approaches. So I've already mentioned I went to Sussex. I had a look at the modern syllabus for the 2021 intake of students. And interestingly, in 25 years, it's not changed. So this syllabus hasn't changed much since the late 90s. Very heavy emphasis on programming, some emphasis on data structures and algorithms. And then you've got the other courses coming in, like computer security, compilers and architecture. I loved that course. Human-computer interaction, technical writing got one little module in one semester, if memory serves me correctly. Mathematics, very theoretical stuff. And again, this isn't about what's right and what's wrong. This is pointing out what we study, depending on where we learn. Just to make sure the University of Sussex is not an outlier, I went and looked at other universities, very much a similar picture. There were some other cool sounding courses like computer music and data science and robotics. That might have been Reading, I'm not sure. But the emphasis remained the same. Heavy emphasis on programming, semi-heavy emphasis on data structures and algorithms, mathematics, the usual stuff that you expect to study at university. So bootcamp, let's take a look at those. Again, this list is going to be smaller because they're not spread over 3 to 4 years, but you start to see something interesting coming in that you start to see some more practical skills. So you start to see things like working with REST services, using the CLI, model and build relational databases. You start to see this more working with Git and GitHub. Oh, my life, we all need that. So you start to see this more practical approach to our jobs coming in. And then I thought, well, what about self-taught? And this is, I confess, I really struggled with this one because it's very different for all of us, right? We all are on different routes. We all learn differently at different speeds. I'm going to go out on a limb and say we do a lot of programming when we're self-taught. And I'm going to say we also do things like learning how to use an IDE, learning how to debug, Git and GitHub, life balance, probably, time management. These are all things that as self-taught developers, we likely learn very, very quickly. And that list is by no means exclusive either. There's plenty more to add to it. So what do we learn? Well, predominantly, we learn to write code. But what do we do once we've learned to write code? And it's probably not great code at that point. But what do? We go out and we get a real job and we become Java programmers because that's why we've put all this effort in. And at this point, our learning changes. We are self-taught, although I did see a tweet today that argued we are not self-taught. We actually learn from blogs, videos, webinars, talks like this, but we choose to consume that knowledge. We choose to come to meetups, we choose to read that blog, we choose to watch that video. So we are responsible for our learning from that point forward. We don't have anybody kind of standing there with a whip saying, learn that or submit that assignment or you won't pass your course. But the talk's called writing code is easy, being a great developer is hard. So I want to talk about the hard. So for the rest of the talk, I'm going to take you through the self-taught skills that I've learned in the last 20 plus years working in tech. I've been part of numerous development teams and I've seen the inner workings of many different product life cycles and the people who create them, including myself. I'm going to take you through each skill, why it matters, and give you some resources where you can learn more. You don't need to write any of this down. There will be a link at the end of the presentation and a QR code for those of you who are so inclined. I will put it in the chat. So all the resources that I put up on screen will be available to you. And they're going to be relevant to you irrespective of your experience. So I'm going to start with what some people may call the easy stuff and then move through the skills in the order that you might encounter them. But let's be honest, everybody's career is completely different. So what might be my path is not going to be your path. Now, if you've been developing for a while, you're probably going to recognize many of them. And if that is the case, I really hope that you just take a moment, step back and recognize them for the independent self-taught skills that they are. They're not just things that magically came to you. You learned them. And I really want you to acknowledge that. And I want you to acknowledge the path and the journey that you've been on, because then when you do that, you can help others who are fresh into the career. And if you're relatively junior in the career, or perhaps you're still drinking at East Slope in Sussex University, they may be new to you, and that's okay. It's better to know what's in store and to recognize that your learning journey is only just beginning. So you can consider this a whirlwind tour of the skills that you're going to acquire on your path to greatness. Right, let's get started. So first skill, Googling, or professional plagiarism, as I call it. And this was weird. Like, I'm going to assume it's still the same at university, but you get thrown out if you plagiarize stuff at university. In academia, it has to be elegant, it has to be unique. If there's a wheel, you must go forth and you must reinvent it. And then you go into your first full-time job. And if you can't Google and Google effectively, people look at you weirdly. And it's more than that. It's about how to optimize your search. It's about how well you could think like other people. Because if you're Googling something and you're not getting a result, you're Googling the wrong thing. It's 2022. You're Googling the wrong thing. I nearly said 2021. It's about being able to pick through the results and understand what is relevant. You all know the joke. What's the difference between a junior and a senior developer? One of them's better at Googling. So it most definitely is a skill and you have learned it. There is a great blog here from Joshua Hardwick. He actually maintains it, which is why I've put it in this presentation. And you might be sat there thinking, well, yeah, I'm pretty good at that. But when you actually start digging down into all the different Google search operators, it is a whole new world. And maybe, you know, a nuanced search operator like finding a page containing 2 words within a certain distance of each other is not that useful. But when you are down a rabbit hole and you have like 32 Stack Overflow tabs open, knowing how to really use Google and use it well can be exceptionally helpful. Okay, next skill, reading code. That's a great film. So here's the thing. We are taught to write code. We are not taught to read code. And when I say that, I speak very much from my personal experience coming from the university route. I recognize it may be different for others, but we are taught to write greenfield code. And this is not reality. Reality is we never go into a job and someone says, create an app from scratch. That doesn't happen. You go into a job and someone says, implement that or fix that. And you have a roll of sticky tape and some prayers. And you have to apply that sticky tape. And in order to apply it, you have to be able to read whatever code is already there. Now, of course, IDEs can help you with this. Of course they can. But it is so much more than that. It is about looking for design patterns. It is about recognizing that code does not tell a story. There's no start, middle, and end. I suppose technically there is a start in Java, but it's not a story. It's not that simple. A couple of resources here for you. The first one from my ex-colleague and friend, actually, Trisha G. So Trisha makes the observation that it's funny that computer language is the only language where we learn to write before learning to read. And it's not uncommon for people never to really learn to read code. And doesn't that seem a little unbalanced, given how much code we read versus write? And when I first read this, I thought, oh yeah, it's kind of obvious. Because if any of you are using, let's say Duolingo, and you're learning a second, third, or if you're really talented, fourth language, I'm certainly way better at reading Spanish than I am at writing Spanish. So it's worth remembering. The second resource is from A&M Basler. And they talk about how you can improve your code reading skills and actually go on to give some helpful strategies for doing that. They do make the observation, again, if you want to write good code, you've got to read good code. And you need to learn to understand how developers and your colleagues think. So things you can do, you can run the code. Seems obvious, right? You can run the code. You can really use and know the tools. So mostly I'm talking about the IDEs at this point, but whatever IDE you use, really use it and know it and understand how it can help you. You can do temporary refactors as well. That can help you to actually understand what's going on in the code. Okay, next skill, doing technical interviews. So this is not a presentation on whether technical interviews are good or bad. This is a presentation that you'll probably have to do a technical interview at some point in your career. And when you do that technical interview, you may be asked to demonstrate some skills that arguably you would not be asked to demonstrate should you be successful at the job. And that is a separate presentation entirely. However, you may be asked to implement something that's a little bit unusual, maybe a strange algorithm, but there's lots of help at hand, and it is worth practicing this skill, because if it's your perfect job and the only hurdle is a technical interview that rubs you up the wrong way, it's worth just getting through that technical interview if the job the other side is something that really excites you. So some great resources here. The first one from Emma Bostian. So she has a book called Decoding the Technical Interview Process and a video as well that can help you to ace it. So if you don't already follow Emma on Twitter, by the way, give her a follow. She produces some phenomenal content and is very, very talented and knowledgeable. Second one from Sarah Kasabian. This one is really interesting because it's a blog that goes from the viewpoint of when they realized at GitLab that their technical interview process just didn't work and they weren't winning and the candidates weren't winning. So they set about changing it. And there's some really interesting metrics and takeaways. If you're on this call and you are in charge or have some influence over the technical interview process and they don't work and you know they don't work, think about changing them. No one else needs to go through that pain. If they don't work for you, see if you can get them changed. Okay. Now, bear in mind, I used to work for JetBrains when I wrote this presentation. I know there are more IDs out there than these two. My point is choosing tools and choosing libraries and frameworks is difficult, and it's not something that we necessarily learn at university. And at some point in your career, you are going to have to start making decisions, and those decisions are going to have far-reaching consequences. Now, when it comes to an IDE, pick what works for you. That is the advice. Pick what works for you. If your IDE is dictated by your company, you're going to get less of a choice. But ultimately, get something that works for you, because that is what will help you to be a better developer. when it comes to picking a library or framework and managing all the dependencies, things get a little bit more interesting. Net new code's not really very common, as it turns out. I was lied to for 3 years. Modifying existing code is far more common, and we rely extensively on third-party libraries and frameworks, and they all need management. There's some really interesting tools. So there's some really interesting blogs that you can read that help you to potentially choose the right libraries and frameworks. This one in particular from Kyla Matthews. Some of the things that are on this slide seem really, really obvious. And it's the sort of slide that when somebody, shows it to you, you're like, well, duh, Helen, that's really obvious. And it is. But I certainly don't go through this checklist, or I didn't when I was considering choosing a new library or a new framework. Like I might have looked at the API, but it's really easy to just go, that one, that'll do, rather than taking a step back and going, well, what exactly do I need? And how popular is it? What's the testing status? Have a play with it. Again, it seems obvious, but it's easy. And I think we've all been there. We've all either done it or been on a team where someone has done it, charged ahead, chosen a tool, and it has bitten really badly months or years later. So it's worth making the decision and really giving it due diligence. Okay, next skill, being a team player. So bad news, team are like your family. You don't get to choose them. Even worse news, you are not really the lone wolf that you were at university. Again, if you collaborate at university, it doesn't tend to go down well unless that was part of the task. So it's really difficult. And it's something that I really struggled with when I graduated, because I was thrown into a collaborative environment and I was like, what? No, I don't have the coping mechanisms for this. I don't know what I'm doing. And I worked on it a lot when I reinvented my career as a technical writer, because I learned something very interesting as a technical writer, and that is no developer wants to see a technical writer 2 days before the release. Literally none. They don't want to see you. And I am not surprised. So unfortunately, in my job, I did need to see them, because I was always determined that the docs were part of the product and they would go out with the release. And I would, stake my reputation and career on it. So I'm always made it my business to get to know the people that I was working with, really get to know my team. And I don't just mean lip service either. I mean, getting to know them, understanding what makes them tick, understanding if they like ad hoc meetings or if they like a regular scheduled meeting, understanding if you approaching them at their desk, I am talking pre-COVID, annoys them or not, understanding if you need to take cake, knowing what's going on in their personal life to an extent. How are their kids? Because if you know all that information, you are far more likely to build a stronger relationship with them. And then when you rock up at their desk 2 days before the release, they are far more likely to help you and recognize that you're under stresses as well and you need to get this job done. My point is, it takes a lot of effort. Couple of resources for you on this one. First one from Offer Vogman, and they talk about how technical skills they're really only part of the story and how teamwork matters. So they talk about things like leaving your ego at the threshold. I have definitely been guilty of not doing that. Embracing feedback, caveat, unless it's toxic. The thing about feedback is it's just somebody else's opinion. Take it or leave it, but definitely don't take it if it's toxic. Be accountable. That is always one that we should always be striving for. And don't be a knowledge hoarder. So this one is exceptionally interesting because what happens if you're a knowledge hoarder is people come to your desk and bug you more because they can't find the knowledge and they can't self-serve. So if possible, get it out of your head and into whatever document repository you have available to you. Second resource for this one is this great blog from Alison Danisco, 10 Ways to Become a Better Developer. So the author talks about creating an environment of psychological safety. Call out with this one as well. What is a psychologically safe environment for me might not be a psychologically safe environment for you. So please remember that is very individual. Encouraging equal participation. amplifying unheard voices. So if somebody is always really quiet in meetings, and then maybe they might say something, you could amplify it by repeating what they've said. You can bring them into the discussion. Maintaining a growth mindset is something that's talked about in this particular blog. If you haven't heard of a growth mindset before, and this one isn't in the resources, have a Google of it. The lady is called Carol Dweck, and the high level notion behind a growth mindset is, instead of putting all your energy into worrying about what other people think of you, return that energy, rechannel that energy to yourself, and just use one little word, and that is yet. So I can't write Java versus I can't write Java yet. And stop thinking about what other people think of you, and focus your energy on improving yourself and growing yourself. There's been a whole bunch of studies done on it. So have a Google of Carol Dweck if you're interested in that, because it's really interesting. At least I think it's really interesting as well. Okay, next skill, solving problems. I've really noticed that there is a certain mindset that goes a long way when you're a developer. And it is one that doesn't come naturally, especially at the start. We want to impress, we want to show the boss how awesome we are, how quickly we can solve problems, and we want to be that talented team member, but it doesn't always work like that. There's also the famous quote from Steve Jobs: everyone in the country should learn to program a computer because it teaches you to think. And regardless of what you think of the quote, there's an element of it, certainly for me, that rings true, because I certainly don't think I had this skill when I graduated. In fact, I don't think I had it until relatively recently. And even then, obviously, it's still growing. It's not a binary thing. It's not a skill you have or you haven't. It's only more recently that I can even step away from a coding problem. Before that, I'd, be sat at the desk crying my eyes out of, why is my code not working? So it's definitely a skill that you learn. The resource for this one that I've called out is from Richard Rees, and they make a very interesting observation about human beings. So here's what we do when we're stuck. We try a solution, and if that doesn't work, we try another solution. And if that doesn't work, we repeat step 2 until we lock out. That is literally how dumb we are. And it's not very helpful. It really isn't very helpful. If anybody works in InfoSec, it's the same as trying to brute force a password. And maybe you'll get there, maybe you won't. But what the author proposes is we actually have a framework for solving problems. So step 1, we understand it. That's normally where I fall down. Step 2, we plan it. Once you understand it, you can actually make a plan for how you're going to solve it. You can then divide. You can divide and conquer. Step 4, if you're still stuck, at which point I thought, well, this is a terrible framework. But if you're still stuck, you can do things like you can debug, you can reassess, you can research. And this is far more effective than that kind of immediate, I'm just going to hit my head against this brick wall until I manage to solve this problem. Because maybe, like today's Wordle, you'll get it in 2, like I did. Or maybe you'll be like the husband coming for help when he still hadn't got it in 5 guesses. So it's worth thinking about a framework to solve your problems. Okay, this is the only annoying GIF in the whole presentation. I will let it play once for those of you who, like Gravity Falls. Writing tests. So this one is a self-own. I didn't write a single test at university. Sorry. In fact, I didn't really write tests in anger I did write tests in my first programming job, but it was only really when I came full circle that I started writing tests in anger and even started trying to learn test-driven development. We're not really taught how to write tests. I expect some of you who've come from like bootcamp routes or self-taught routes are way better at this than some of us who have come through academia. But it's just one of those skills that, again, we have to learn, we have to acquire. There are plenty of Java testing frameworks out there. Of course, there are JUnit, Mockito, Spock. Great developers really understand the value of tests, and that writing code includes writing the test. It's about having the confidence in your code and understanding that testing goes a really long way to achieving that. There's a great blog here, slightly passive aggressive, but I kind of like that. Even if you don't, someone will test your software. And if you worry about who will maintain your code after you're gone, then write good tests. So they talk about who should perform that testing, what portion of it should be manual testing, what those tests mean for your main branch. And the point that I think is the most interesting for me, how those tests can give you confidence when it comes to changing your code as well. Okay, next skill. Working with VCS. I've put Git in brackets there because I think most of us have probably interacted with Git either personally, professionally, or both. My version of source control back in the day was zipping up my code and putting it on the desktop. So we've come a long way from that point. You will find that you will quickly become proficient in Git. You will be able to clone, you will be able to commit, you'll be able to do a basic merge, push, update, all the fun stuff. And then things will go wrong. And this happened to me when I was creating docs at my 2 companies ago. And I thought, I know, I'm going to put the documentation into Git because it made a lot of sense. And it still makes a lot of sense. So I charged forward with this project to put all my documentation into Git because it was XML. It was, it was perfect for it. And I got the basics very quickly. And then I started screwing up. And I screwed up in a number of innovative, very cool ways, to the point that the resident Git expert on the team, lovely gentleman by the name of Paul, he did a lunch and learn for the whole company, or for all of the developers at least, of all the innovative ways that Helen had screwed up Git. And this was really well attended. And I thought 2 things are possible. Either it was well attended because everybody wanted to laugh at me, possible, or it was well attended because people wanted to learn the knowledge that Paul had and had been using to extract me from my numerous Git holes that I'd got myself into. I would really encourage you to go beyond the basics with Git. I know for many of you, you'd be like, yeah, I've got that. And great if you have. But for a lot of us, we can get past the rebase or get past the merge. Maybe we can handle a rebase, but beyond that, we don't really want to know. We'd rather delete and reclone the repo. Help is at hand. There is a great book from Katie Solomon-Miller called Oh Shit Git or Dang It Git, depending on how you feel about swearing. And I really like this book because it goes from the problem perspective. So it goes from the perspective of, damn, I accidentally committed to the wrong branch, or I need to undo a commit from like 5 commits ago, rather than, oh, my Git history looks like this. I'm not really sure how it got in that state. So it's a much more human-centric approach to it. The next slide, and finally, I'm giving this presentation when Tom Cools is actually on the call because he shared this resource with me. So this is from Peter Cottle, and it is Learn Git Branching, and it is a brilliant visual representation of how Git works. And it starts at the beginning. And if you know how Git works at the beginning, you can quickly fly through those stages. In fact, I think it may even allow you to skip level to certain Git commands so you can really understand what's going on. So definitely check that out if some knowledge is a little bit more woolly than perhaps you'd like it to be. Okay, reviewing code. Yeah, this is a painful one. Nobody reviews your code at university except the lecturers, and they just go, yeah, I'm going to grade it. They're not going to review it, though. They're not going to give it back and say, well, you could have used that construct, or you could have done this. And then we go into our first job and we have to review code. What is that about? And no one teaches you how to do that. Now, again, code reviews can be toxic. Caveat, different presentation, especially if, the reviewer comes back with similar to the meme there. But it's very easy to say your method doesn't follow convention, or why have you used that loop construct when you could use this one? But experience will tell you what to focus on and what to give feedback on. The other thing I want to point out with this is it's worth remembering when you're participating in a code review, you can only see the code that's on screen. You can't see the 5 other things that the developer discounted before they wrote what's on screen and committed that. You don't know the 5 other things that they thought about, discounted, why they discounted them, why they went with this. So those are all really good questions to ask as well. Couple of resources for this one. First one from Andrew Jones, another one you should be following on Twitter if you're not already. So Angie has gone from the very human perspective of 10 commandments for code reviews. So how not to take it personally. That's really hard at times. Detaching yourself from the code. It is not your baby. Contributing your rationale to the code review. So that goes back to what I was saying of why did you implement it that way? There will be a reason, and you should be able to explain that reason because it will be a good reason. And maybe in explaining that, you'll be like, actually, yeah, no, maybe I shouldn't have done it that way. Of course, compromising and treating others how you'd like to be treated as well. Second resource here is from Dr. Michaela Grayler. There's 2 links there. It is the common problem, and if you haven't experienced this in your career yet, you're lucky. If you have, I'm sorry. Some teams fear and experience pain when they're doing code reviews. They get reduced code velocity, and then the code reviews themselves aren't useful, and then you just have a completely demotivated team because they can't go quickly and they're not getting useful feedback either. So have a look at those links because she talks about what you can look for in code reviews and which feedback is most important. Also with code reviews, if you've got juniors coming into your team, not necessarily junior developers, just people who are new to the business, you can invite them to code reviews with more senior members of the team because they might say, so why have you implemented it that way? And it's a really safe, non-confrontational way to have a discussion about that code because the junior is saying, help me understand. And then whoever wrote the code can say, sure, I'll help you understand. And maybe at that point, you might think, yeah, actually, there is a better way of doing that. So it's a really nice, safe way of checking out code. Okay, next skill, debugging. Bit of a cell phone slide, this one as well. If we were actually in a room, I'd say hands up who still debugs with sysout statements. I certainly do now and again. It's not very efficient and it's not very fast. IDEs were not around when I learned to code. They are now, and they are incredible in terms of what they can do for us. IDEs, again, irrespective of which one, they have, I believe, built-in debuggers, and they are incredibly valuable. And I would encourage you to learn how to use them, but learn how to use them before you need them, because there is nothing worse than a P1 bug and support breathing down your neck, and you need to use the debugger and you're not quite sure how to get the information that you want from the debugger. So there's that aspect. There's also the aspect of an open mind to progress them as well. You really do need that. Somebody else to follow on Twitter if you're not already, Julia Evans. When I wrote this presentation, Julia put this very timely tweet. I was like, does she know I'm writing this presentation? Because she really wanted to understand why we find bugs so hard, why they feel just impossible, and why we just want to sit there and cry. Now, Julia's since collated all the information, so I encourage you to go there and check it out. She's written a blog about it. But she came up with these 5 reasons that it's hard to reproduce, your mental model is missing something, you don't have the tools to inspect the program state, one of your assumptions might be wrong, or the bug's just really, really complex, right? That might be a thing as well. Okay, estimating stories, my fave. So again, you're at university and the lecturer says you have 3 weeks to complete this assignment, and you go, great, I've got 2.5 weeks for drinking and half a week for the assignment. And then you go into your first job and somebody says, how long will this take you? And you have no idea. And I was wondering why estimating stories was so difficult. And I was really looking for something to back up my theory that it's really, really difficult, because we have all this pressure. We want to undercommit. We want to over-deliver. There's a lot going on here. But I found this amazing blog of why it's so difficult. So you're going on a camping trip. It's going to be in the UK. There's going to be 6 to 10 people. It's going to last 3 to 5 days. You know, it might rain. People eat different food. Buy some drinks, not too many. They're quite heavy. Don't forget about the tea. We're British. Get the best possible quality. Now, before you even step foot inside the store, tell me how much the bill's going to be. And that's what estimating can be like. So it's all about breaking down the work, asking the questions, ask all the questions. Take your degree of confidence into account as well. That can be a really useful one. My favorite, don't forget about the things that we tend to forget about. Now that is open to interpretation deliberately, but I just want you to remember that you are human and you have a lot going on beyond just writing code. Second resource is for estimating from Maddie Osman, and the author comes up with 4 reasons why we suck at estimating and how to fix it. So Parkinson's law, it will take as long as you give it. Everyone is different. Thank goodness for that. Software development is a process. It's not just writing code. Hopefully you're getting that by now. And it takes time to get into the zone. Right? I can't roll out of bed and roll into here and, switch on my laptop and go, right, let's get to it. I need tea, I need breakfast, I need to work out, I need to say hello to the husband, I need to do all this other stuff, right? It takes time. So don't forget to factor that in. Deleting code. I was so happy when I found this meme, by the way, or this XKCD, I should say. So again, we are taught to write code. And then we get the code and we put it on a little pedestal and we put a little spotlight on it and we admire it because that's what we're taught. And we're never taught that perhaps code shouldn't live forever and that all code should have a life cycle. And we can iterate on code really quickly, as it turns out. And we're certainly never taught to delete code. It is another place where your IDE can help. I know IntelliJ highlights unused code. I expect a lot of the IDEs offer various support for it as well. One particularly interesting point on this one is don't just comment it out, because that is what version control is for. And when I was looking for interesting resources to share with you, I came up with this slightly aggressive blog with this statement that I'll delete your commented code without reading it, and I'm not sorry. And I thought, wow, that's intense. But the author does go on to give various ways that you can help a code base that is suffering from this and how you can catch it before it becomes this comment junk. And you can do various things like uncomment it, see what it does, turn it off or on if it's a configuration. If you do have a code base that is accruing or indeed has any of this so-called comment junk, it might be worth tracking in terms of why that is happening, because it might indicate maybe there needs to be some training with your version control system, or maybe somebody's just not comfortable, or a lack of knowledge. So that's definitely worth knowing about. If you're not convinced that commenting out code is a bad thing, this story is a little bit old, but New York Stock Exchange, new software system, launched 1st of August. They deployed an update to their 4 servers. One of those updates failed, left the old version of the software running. In the new version of the software, they'd recycled an old flag. That flag was no longer used, but it was now repurposed. It meant something different. Hadn't been used in 8 years, in fact. The old code still had a dependency on that flag. The system went live. The zombie apocalypse arrived, and it was awakened by this new software, and it resulted in a loss of $10 million per minute for 45 minutes before they could get the system offline. So be careful. Okay, next skill, pair and mob programming. So this is a really powerful one, right? This is really cool for learning and growing your skill set. 2 heads is better than 1, mostly. Mob programming, derivative of pair programming. I did a lot of it at JetBrains. It is mentally exhausting, but incredibly rewarding. Those are 2 conflicting things. I would encourage you to find opportunities for you to pair program. Turn up, give it your best shot. Don't turn up with a hangover. Terrible idea. You can learn and teach a lot from doing pair programming. And if your colleague uses the same IDE as you use, you can get all their shortcuts as well. Added bonus. First resource for this one from Sam Fair. So they talk about mob programming. And of course, mob programming is not disorganized, prone to rash decisions, angry, unwilling to compromise. It is quite the opposite. I've never actually done mob programming, so I found this to be quite an interesting read because it's all hypothetical for me, having never done it directly. There's also this blog from Nat Bennett. Now, this author was part of an experiment for 6 years They paired all day, most days for years. Hundreds of other engineers did the same. And they often paired for 8 hours a day. And they make the observation that it was one of the best things he's ever done for himself, socially and emotionally. And it produced some great software, but it also burned him out. So it's a balancing act, as always. Very interesting read, that one. Okay, next skill. How am I doing on time? Okay, 9 minutes, easy. Managing meeting load. Again, if we were in a room, we'd be like, hands up, who likes meetings? Nobody puts their hands up. So I have worked with people who have been so proud of the number of meetings that they've had in the day that they've shared it on social media. And my head was just like, don't understand what's happening here. But it really drove home to me just how little code we get done when we're in meetings and how frustrating many of us find that. Meetings also come with a really heavy context switching cost. It's very asynchronous at university. It's like, do this, do this, do this, do this. And then we get into the real world and it's like drinking from the fire hose. We really have to learn to use our time wisely and learn to group meetings. This is very, very interesting read. Turns out developers don't really hate meetings. Turns out what we don't like is inefficiency, poor planning, not delivering on expectations, missing deadlines because of meetings, and not getting enough time to do our jobs. So that's not the same as not liking meetings. Remember, if you're a dev and you go to a meeting and you are enjoying it, you will get your dev card pulled. There's some helpful tips in this blog. So you can take a meeting inventory. You can establish what your monthly baseline is. Don't forget the ad hoc meetings. All the time the product owner comes up and wants something, for example. What's the value of each meeting? What's the positioning of each meeting? Can you group those meetings? Can you improve the project transparency? It goes back to not being a knowledge hoarder. Okay, switching contexts. This one's hard. You are always going to get planned and unplanned things thrown at you in life. You are going to be sat there and get that phone call that nobody ever wants to get. You're going to be sat there and have the product owner come to you and say, it's all changed and the sprint is out the window. We have 3 P1 tickets on support. You're going to drop balls. Others are going to pick them up. Life's going to throw them at you and it's never going to stop. And there is a cost that you have to factor in, especially when you are estimating. And that cost is something called attention residue. And I hadn't even heard of this phrase until I came across this blog. And it is fascinating because attention residue is where your brain cannot switch off from one task and straight into another. I used to think I could do it and I can't. And it's actually incredibly difficult. It's like when you group meetings, you have a meeting at 9, 9:30, 10, 11, 11:30, 12, and you get to 1 and you're still thinking about the meeting you had at 9 in the morning because your brain can't do it. It can't just switch off that quickly. It can't process that fast. It's at odds with how we work. There is some advice in this blog as well as everything that our brains can't do. Scheduling time for regular deep work, setting times for managing daily communication. Maybe don't open your email first thing. Use anti-distraction apps, which I find kind of meta because I'm like, you want me to put an app on my phone that distracts me to stop me getting distracted by my phone. But a better one might be to practice digital minimalism. So just put your phone away for a little bit. That can actually really help. Can't do a presentation like Grumpy Cat. Nobody wants to say no. You don't want to annoy the boss. You don't want to let the team down. You do want to progress your career. Sometimes you just have to say no. Actually, a lot of the times you have to say no. Burnout is real. Many of us have learned that the hard way. You have to set boundaries, and it goes back to setting priorities as well, because you can come out the gates as fast as you like, but it is not a sustainable speed. A couple of great blogs for you for this one. Hussey and Pollitt-Urich. This one is fascinating to me. Like every line of code has to be read and understood, tested and debugged. It's going to introduce new bugs. Maybe you could say no to writing that code. And I was always like, oh, I'll say no to the meeting. I'll say no to this. I never thought about saying no to writing code because I'm like, well, that's my job, right? I have to write code. So that's quite an interesting point of view. Second blog from Danila Petrova. You're going to feel pressured. If you haven't felt it already, you will. and you are going to try and debug your working process to find out how you can do more in the day. You're going to get up earlier. You're not going to stay in bed when you have that first cup of coffee. You need to start saying no. And she actually goes on to give some ideas for how you can say no, which I know a lot of us struggle with. I certainly struggle with. How you can examine your caseload before you give a reply. So how you can say no, you can be respectful and honest, and you can offer up an alternative as well. All right, coming towards the end. Please be aware of your mental health. If you don't already know, it's a fast-moving industry. It is. And it, like any job, it can take a detrimental toll on your mental health. It is the importance of mindfulness, the importance of rest, and the importance of having those around you. I just want to remind you all, and I know it's a crappy thing to remind you all, but we're still in a global pandemic and it's been 2 years. This is still not normal. And your support network is not what it used to be. And it's fine. A lot of us find ourselves on the road to burnout, and it is horrifyingly common in our industry. So I'd encourage you to take the time out, recognize when you're on that path, ask for help and support from those around you, because many of us have learned the hard way, and it's not a nice way to learn. I do also want to say on this point, you do not need a side project or a side hustle to be a great developer. You do not need to code on your weekends. If that makes you happy, go for it. But some of the best developers I know work 9 to 5 and that's it. And that is what they do. And they are amazing at what they do. Blog here from Lena Kozar and Voba Vok. They talk about 4 tips that can help us to be more aware of our mental health, focused and unfocused modes. That's carving out that time for deep work. Working out is everything. Take a walk. If you want to do 100 burpees, do 100 burpees. Do what makes you happy. Work with your team, talk with your team, help your team help you. Oxytocin, turns out, not just useful in childbirth. It's your happy hormone, and there are lots of different ways that you can get hold of some, workouts being one of them. It's a very interesting blog, actually, because this one, it mirrors some of the more human aspects. So things like multitasking, imagination, brain power, to words that developers are going to be more familiar with, like memory, video cards, and processors. So it's kind of a good blog to nerd out on. Brian Robinson also has these 2 articles that really drive the point home. And I know I'm laboring on it, and I'm laboring on it because it's important. This is not even technology specific. I expect these figures are higher outside of technology. 48% of people have experienced burnout, 61% elevated stress, 32% felt lonely. Those are crazy, crazy figures. Read the second blog if you are currently working for a company that is going with a hybrid working model between office and home in the pandemic, because there are some red flags that psychological safety that may be lacking if certain things are happening, like reward only happens in the office, or no senior leaders work remotely. So something to be aware of just in case it applies to you. Right, last skill, have a great work-life balance. It's so important. Your family, your friends, your hobbies, make it work. Wherever your computer is sat at home, like many of us are at the moment. If it's on the dining room table, see if you can just shove it in a drawer overnight. I appreciate that's not always easy, but whatever you can do to put that separation in, I would really, really encourage you to do that. First resource on this one from Anu Padye. Work-life balance tips for programmers. Again, they seem obvious, but it's really worth calling them out. So prioritizing your time, strict routine. I definitely find that one very helpful. Don't be a perfectionist. It is the enemy of good. Learn to say no and try and enjoy yourself. Now, I'm not going to ruin the story here, but that blog has an embedded TEDx video, and it's about when his wife calls the guy up and says, I need you to pick up our kid. And he makes a small, insignificant change. So the effect that it has on his kid, though, is astronomical. Get the tissues ready for that one. So to summarize, writing code, it is the easy part. It's what we're taught and it's what we learn. But being a great developer is hard. And it's all the other stuff that we learn on the job that I want to call your attention to. So this is your call to action slide. There's going to be the QR code and the link on the next page, but I will put that in the chat. But this is also the part where you give yourself a huge pat on the back. You're generally rather awesome and you're doing this stuff. And I don't know if you even realize that you're doing it. You don't just write code. I couldn't even fit everything else in this presentation. This is the part as well where you go and help somebody else who is new to the industry. They might not have these skills yet. They probably don't have these skills. They might recognize they need them, but they're probably not going to have them. You don't just pick them up overnight. But this is the part where you can show them the way. So that is the QR code and the link, which I'll put in the chat presently. And that is it. Thank you so much for listening.